Welcome to Universe Secrets. Today, we embark on a journey to the largest planet in our solar system, the mighty Jupiter. For centuries, astronomers have gazed at its swirling bands and storms, labeling this colossus as a simple gas giant planet. We often imagine it as a massive balloon, a sphere of gas with no solid surface to stand upon anywhere. However, modern science reveals a startling truth. Jupiter is not merely a gas giant, but actually a massive liquid planet. Deep beneath those thick clouds lies a strange and hostile world, fundamentally different from anything we experience on our Earth. To understand this liquid behemoth, we must look back at the history of how we discovered its true, hidden nature. Early observers could only see the tops of the clouds, assuming the entire planet was just a puffy ball of air. But as our technology advanced, we realized that calling it a gas giant is a significant oversimplification of reality. The flyby missions of the late 20th century gave us our first close look at the violent dynamics of this world. We saw storms larger than continents and winds faster than any hurricane, hinting at a powerful energy source deep within. A pivotal moment came in 1994, when the comet Shoemaker-Levy 9 collided violently with the southern hemisphere of Jupiter. The world watched in awe as fragments of the comet slammed into the atmosphere, creating explosions larger than the Earth. These dark scars prove that Jupiter has a dense atmosphere capable of absorbing impacts, acting like a cosmic vacuum cleaner. To truly understand what lies beneath, we sent the Galileo probe on a suicide mission directly into the crushing depths. As the probe descended, it transmitted critical data about temperature and pressure before being crushed by the immense weight above. The data revealed a terrifying environment where the pressure increases so rapidly that gas is forced into a liquid state. Let us explore these layers. The top layer consists of ammonia clouds, creating the white and brown bands we see. Here, lightning bolts strike with intensity 1,000 times more powerful than any storm ever recorded on our home planet. Scientists have discovered a strange phenomenon here called mushy hailstones, balls of ammonia ice wrapped in a layer of water. As these slushy balls fall, they melt in the deeper, warmer layers, creating a constant cycle of exotic alien rain. Descending further, the sunlight disappears completely. You are now in pitch blackness, surrounded by crushing pressure and rising heat. At this depth, the distinction between gas and liquid begins to blur. We enter the realm of supercritical fluid. Here, the hydrogen atmosphere becomes so dense that it behaves like a liquid, yet maintains the temperature of a gas. This is the start of the liquid ocean, a layer that makes up the vast majority of Jupiter's total mass. This ocean of liquid hydrogen extends down for 20,000 kilometers, dwarfing the deepest trenches found in our Earth's oceans. Even though the temperature soars above 1,000 degrees, the crushing pressure keeps the hydrogen in a dense liquid state. The Juno spacecraft, arriving in 2016, used gravity measurements to map this hidden interior with unprecedented precision. Juno's data confirmed that Jupiter is not a hollow shell of gas, but a dynamic body of rotating fluids. As we dive deeper still, we encounter the most exotic layer of all, known as the metallic hydrogen ocean. Under pressure, 2 million times that of Earth, hydrogen atoms are crushed until their electrons are squeezed loose and free. The hydrogen transforms into a metal, behaving like liquid mercury, capable of conducting electricity and generating massive magnetic fields. This swirling metallic ocean acts as a planetary dynamo, creating the strongest magnetic field in the entire solar system. It is this internal generator that creates the spectacular auroras we observe dancing around Jupiter's north and south poles. But what lies at the very center? For decades, we believed there was a small, solid rock core. Textbooks used to depict a solid ball of ice and rock, similar to Earth, hidden deep inside the gas. Juno shocked scientists by revealing a fuzzy core, where rock and ice are dissolved into the liquid hydrogen. Instead of a solid ball, the core is diluted, spreading out across nearly half of the planet's total radius. Some theories suggest a massive impact early in Jupiter's history may have shattered the original core, mixing it up. Imagine a planet 10 times the mass of Earth crashing into Jupiter, stirring its contents like a cosmic blender. This event would explain why the core is so diffuse and why heavy elements are spread throughout the interior. So, Jupiter is not a gas giant, but a world of liquid metal and dissolved rock, wrapped in clouds. From the stormy atmosphere to the metallic ocean and the fuzzy core, it is a masterpiece of fluid dynamics. This new understanding challenges our models of how planets form and evolve in our solar system and beyond. It also raises questions about the moons orbiting this liquid giant, influencing their potential to harbor alien life forms. Jupiter acts as a miniature solar system, a king ruling over a diverse family of unique and icy moons. The polar storms, arranged in geometric patterns, continue to baffle scientists with their stability and complex atmospheric physics. We observe the belts and zones changing color and intensity, driven by the heat escaping from the liquid interior. In fact, Jupiter radiates more heat into space than it receives from the sun, proving it is still cooling down. This heat is a remnant from its formation 4.5 billion years ago, trapped deep inside. As it gathered mass, gravity compressed the core, generating the immense heat that still powers the storms today. Scientists continue to analyze the treasure trove of data sent back by Juno to refine our planetary models. Understanding Jupiter's magnetic field helps us understand exoplanets orbiting other stars in our vast Milky Way galaxy. Are Saturn, Uranus, and Neptune also liquid worlds in disguise? Jupiter provides the key to unlocking their secrets. Future missions will dive even deeper, perhaps dropping probes that can survive longer in the crushing liquid environment. Imagine a camera floating in that metallic ocean, seeing a world where hydrogen flows like molten silver lava. It is a place forbidden to biological life, a realm of extreme physics that tests the limits of imagination. Jupiter spins faster than any other planet, completing a day in just 10 hours, bulging at its equator. This rapid rotation contributes to the violent weather and the mixing of materials within its deep liquid interior. The bands we see are actually jet streams moving in opposite directions, fueled by the planet's internal heat. Juno discovered that these winds are not just surface features, but extend thousands of kilometers down into the liquid. At a certain depth, the winds stop, stopped by the magnetic drag of the conductive metallic hydrogen ocean below. It is a perfect interaction between fluid dynamics and electromagnetism, playing out on a planetary scale of grandeur. The auroras here never stop, powered by the planet's rotation and volcanic particles spewed from the moon, Io. This connection between Jupiter and its moons adds another layer of complexity to this already mysterious liquid system. As we look back at Jupiter, we no longer see a simple ball of gas, but a dynamic world. We see a liquid planet, a vast ocean of hydrogen and metal, hiding secrets about the solar system's birth. Its fuzzy core alone is larger than our entire home planet, a testament to the immense scales involved. Yet, many questions remain. How exactly did the core dissolve? What drives the precise geometry of the polar storms? Mission extensions for Juno and future probes will hopefully provide the answers we seek in the coming decades. Until then, we can only marvel at the beauty and terror of this liquid giant hanging in the dark. Jupiter reminds us that the universe is far more complex and stranger than our human intuition can grasp. It challenges our definitions, forcing us to rewrite textbooks and expand our understanding of what a planet is. As the eldest sibling of the solar system, Jupiter holds the history of our cosmic neighborhood inside its layers. Unlocking its secrets brings us one step closer to understanding how our own Earth came to be habitable. Every storm, every layer of liquid metal tells a story billions of years in the making, waiting for us. The extreme conditions inside Jupiter are nature's ultimate laboratory, testing the laws of physics to their absolute breaking point. By viewing it through different lenses, we peel back the layers of mystery, revealing the liquid heart within. We owe our knowledge to the robotic explorers that plunged into the abyss, never to return to the stars. Their final transmissions transformed our view from a simple gas ball to a complex, multi-layered liquid world. So the next time you look up at the night sky and see that bright wandering star, remember this. You are not looking at a cloud, but at a deep, dark, and storm-filled ocean of liquid hydrogen. A world where rain is ammonia, the air turns into liquid, and the core is a fuzzy mix of elements. Jupiter stands as the king of planets, guarding the secrets of the solar system in its crushing liquid depths. Its great red eye has watched over us for centuries, and now we finally have begun to look back. The journey to understand Jupiter is far from over. There are still depths unprobed and mysteries left to solve. Thank you for joining us on this deep dive into the liquid heart of our solar system's giant. If you enjoyed uncovering these cosmic secrets, please like this video and subscribe to our channel for more. We release new videos exploring the wonders of the universe every week. Stay curious and keep looking up. This is Universe Secrets, signing off. See you in the next adventure across the stars. Goodbye for now. Universe Secrets, exploring the cosmos, one video at a time. Thank you and have a wonderful day ahead.